back to our reference character, we're just going to take a look at possible ways of setting up legs and feet. There are several different methods for doing this. In this character, though, it's set up nicely. As you can see that as I move the waist of the character around, the feet try and stay on the floor as best as possible. Only until I exceed the length of the legs do the feet pull off the floor. We're actually going to better that one, and we're going to make stretchy legs for our character and allow the leg to get longer so the foot always stays locked to the floor. For the foot controls, we're also going to set up the same kind of foot roll slider that I have here. What this basically does is allow us to, I'm just going to make the legs bend a bit so it doesn't, so it rolls correctly. What this allows the animator to be able to do is be able to roll up onto the heel all the way through the toe and up onto the toe. And you can actually see that the ball of the foot starts to roll first and then rolls onto the toe. This is more of a correct action. We could even have separate controls for each roll as well as one master that does the whole thing. In this foot rig, I've also added a side-to-side control, and one that we will be adding in our demonstration, which is a toe control up and down, so we can wiggle the toes up and down. Having some really refined controls for the feet is very important for the animator, as one of the things you never want to have happen in animation these days is have the feet slide on the ground during an animation. This makes very unrealistic animation, and it used to be a problem about 10 years ago to solve this, but no longer is that a problem. Let's get started on creating the bones for the leg. Again, in Create Systems, Bones, let's set the bone size again so that it actually has the correct height, width and height for its length. And I believe we are using about a value of 2. Let's just check that. That's correct. Each time you restart Max, these values have to be reset, but we'll keep their values from one Max session to Max session as long as you haven't shut Max down, or Max file to Max file. We're going to need a thigh bone, calf bone, and then we'll build the foot rig separately because we're doing a reverse foot rig, so the bones actually go in the opposite direction. For the thigh bone and the calf bone, I start up top, and I always add a small nub bone to start with. You'll find out later why this is. It helps when you're actually linking and unlinking your character's leg if you have an IK solver on it. Down to the knee and down to about where the ankle is, and right-click to end. For the foot, I'm going to create a reverse foot system. The reverse foot system basically is going to start at the heel, go to the toes, then back to the ball of the foot, and then it'll be eventually lined up to the ankle and the bottom of the joints for the leg. I'm going to select all the bones, move them over into the correct spot. Working in view space, I'm going to rotate the leg so that the leg joints line up with the angle of the leg. This character is a bit of a problem with the direction that the knee points in, and it's a little bit harder to set up than a character that would have completely straight knees and feet with the body. Now that I have it rotated about correct, we need to start sizing the bones and making sure that they're in the correct spots. Open the bone tools, and again we're going to use the bone edit mode for this, so we can adjust the pivots of each bone without affecting the others. Again, I'm going to work in local space now so that I don't accidentally move the bones side to side. One of the things you need to make sure in an IK solve joint is that the solver plane remains flat. At no point do you want to move this knee joint sideways. Doing so will create a joint that actually bends through the flat solver plane, which is this point to this point to this point, creating a triangle. If you bend that joint sideways, it will no longer bend towards you in the direction that you expect. I'm going to place the ankle joint as well down where the ankle needs to be. The hip joint is going to be quite high up in the character. You can feel where your hip joint is. You can feel where the bones start for your hip. And they are quite high up. Actually, where I've got it placed is quite good. And we'll see how that is. Once we're actually skinning the character, moving the bones around is very easy with the skin modifier. This is one of the great advantages of using it. For the foot now, let's align the nub bone of the foot up to the bottom of the leg so that it's aligned up and the rotation point is in the same spot. Just do that with position X, Y, and Z. The ball of the foot needs to be somewhere around the toe joints. Now, for this character, if I was going to get really fancy, I would want separate joints for each of the toes so that I could curl the toes individually, separate them out into different animations. If the character was going to have shoes on, there's no need for this really. For this demonstration, we're basically just going to use the single foot roll setup. The toe is going to have to be located somewhere. The toe roll that will make sense. That's going to be out front of the toes somewhere. And again, this becomes a little bit difficult because of the shape of his toes. But I'm going to assume it's going to be about there. Checking our grid, we can make sure that we haven't gone down below the ground plane as we rotate this. You may even want to move it up higher for the try and take into account the curve of the toes. The heel joint we want to place so that we can actually roll the heel up on that pivot point. Placing it somewhere right behind the heel should look pretty good for us. I'm going to turn off bone edit mode now and show you that what I'm going to have is the ability to be able to control the foot from the heel to roll it up onto the heel, control it from the toe to roll it onto the toe, control it by rolling it at the ball, and then eventually having IK solvers on the leg that will bend the knee joint as this lifts. We need one more joint, and that joint actually is going to be a joint for the toes to be able to wiggle the toes up and down. Right now we have no method of being able just to wiggle the toes, and you need to do that often. Good way to do that, I'm going to hold down Shift and rotate and just create myself a new bone. It's still linked up to the system, so I'm just going to unlink it for now, or press the unlink button and to place it where I need. It's also best to have a nub bone on it so we can change the length, and again, create end is perfect for that. Where we want this joint to be is aligned positionally up to the ball of the foot. And then we can set the length of the bone as we're going to need it. It only needs to be close because we can change the size of envelopes and skin weighting as we need. Turn off bone edit mode again. And this time what I'm going to do is I'm going to link this bone back into the system. We want this joint to stay aligned essentially to this toe roll joint. So I'm going to link it to that bone. Now we have the heel roll, toe roll, ball roll, and we have a separate toes up and down. So we have pretty good range of motion now for the foot. The next steps will be creating an IK solver to control the legs, and then a control object will be placed under the foot so that we can lift and rotate the ankle joint. It'll be this control object that will hold the custom attributes that we'll use for creating the foot roll. For the control object, I'm going to start with a rectangle. Once again, the rectangles, or just shapes in general, are very nice because we can shape them to make them feel like the thing that they're controlling. I'm going to line this up so that it's aligned properly to the leg. And a very easy way to go about doing that actually is by taking the Z value from the top joint and applying it to the rotation of the foot. Control. If we then want, we can change the length and width values to get it closer to what we need. Let's adjust the size of this and shape of this so it better fits the foot. I'm going to collapse it to an editable spline. Pick all the vertices, set them to smooth, then I just adjust the shape so it looks a little closer to the foot. I also like to keep the controls out from the foot a fair bit so that it's easy for the animator to grab. If you make the controls too close or settled inside the objects, then it's difficult for the animator to be able to grab them. Next, we need to get the pivot in the correct spot. Currently, right now, if we were to rotate the foot during animation, it would rotate in the middle of the foot. This isn't what we want. There's a couple of different placements you could try. Moving it to the ball of the foot is a good one. However, every single time that you rotate the foot at that point, you'll be moving and adjusting the placement of the knee. I like to try and isolate the rotations and movement of characters as much as possible so you can pose one part without affecting the other, just like we did in the spine. I find one of the best spots for the pivot of the foot control is actually at the ankle. I'm going to go into the hierarchy panel, pivot, affect pivot only, which is the bone edit mode, as well on. And now I can adjust the placement of this. I'm going to use the align tool again, and I'm going to line it up to the nub bone at the bottom of the leg in position X, Y, and Z. Now you can see when I rotate this, it'll rotate about the ankle joint. Once the rest of the foot is linked and hooked up to this, it will rotate with it in the same place. To start with linking the foot, I'm going to grab the heel bone, which is the last joint basically in the foot, and I'm going to link it to the control object. Now the foot can rotate around the bottom of the leg. For the IK solver for the leg, it will not start at the very top nub bone. It'll actually start on the thigh bone. The reason for the nub bone is IK solvers need something to orientate them when linking and unlinking characters. If this is going to be a game character, you might want to leave that nub bone out just because it adds another node into the rig. And you just have to work a little more carefully as you're linking and unlinking objects. In my case, I'm not worried about this. So I want to start with the thigh bone, and we're going to use a high solver. High solver is basically what's called a history independent solver. That means it is not dependent on the history of the scene. An HD solver is history dependent. This is an old type of IK solver that was used in previous versions of Max before version 4. The problem with the history dependent one is that it has to calculate back to 0 each time for each frame. This can make it very slow later in frames if the scene is very long, and it also can make it very inaccurate for trying to loop scenes. IK Lim Solver is basically a high solver that only does a 2-bone solve. I don't tend to use it. It was set up for the gamers so that it will only export a limited amount of data. So I want to choose high solver. Again, I get my dotted line looking for what the bottom joint will be. That will be the nub bone on the bottom of the leg. And now I have an IK solver that controls the bending of the knee. The size of the solver is really large. The goal, and this is called the IK goal down here, this large X. I want to change the goal so it's a little smaller and doesn't get in our way. Try a size of 4. The IK solver now, I'm going to link to the nub bone of the foot. We now have a semi-complete foot rig where I can rotate it on the heel to lift the foot on a heel roll. I can rotate up into a toe roll, roll on the ball of the foot, as well as I can rotate the entire foot, as well as move it. The leg will bend. Now one nice feature to have is if we rotated the foot side to side, we really want the knee to stay aligned to the foot. We can do that by selecting the IK solver, and in the motion panel we're going to work with the parent space. The way an IK solver works is that it uses information from either the IK goal end or the parent space, which is this little first joint we created up top, to decide what its angle is going to be based on. It's currently set at start joint, which means that it's taking the angle of this joint. If I rotate this, you'll see that the knee rotates. If I set it to IK goal, it will use whatever the goal is linked to. If I go back and pick this bone up top, you'll notice the knee no longer rotates with it, but instead now when I rotate the foot side to side, the knee stays pointing in the direction of the foot. This is more likely what you're going to need during animation. We're going to also add an override control to be able to control the angle of the knee as well, so we can make subtle adjustments to it. To finish this off, I'm going to color the control object and size it up so it's a little more obvious and can be seen better. In the editable spline, I'm going to change the thickness to 0.5 so it's a little bit easier to grab a hold of. And I set the color to be a green, dark green color for my right-hand controls. I use red for the left-hand controls. You can pick and choose what you like. I'm basing the colors for left and right from sailing and airplanes, where they use port and starboard, which would be red and green corresponding to it.